So now that we've gone over what branching and comparative statements are, let's write out some examples and figure out exactly how this works. So first thing we're going to look at here is this problem. So say we have two numbers stored in A and B, and I want to move the greater one into a variable called max. So let's write out a program for this. Alright, so I want to start off by declaring a constant. So I declare my variable, sorry. I want to declare my variable here, and I'm just going to call it max, and I'm going to reserve 1 byte inside memory. At memory location 800, I have my variable max, and it's reserved 1 byte for me. Cool. So now, I already know I have my A and B registered filled with numbers. So let's start writing out my code. I want to reserve this at memory location 1000 because that's where my ROM is at. So I'm going to start off. We have one instruction that compares A and B. So let's use it. So let's compare A and B. And now what that's going to do is just check if A is greater than B, greater or equal to, or if A is less than or equal to B. Very easy stuff. So next, I'm going to use conditional statements to store either one in A. I'm going to store either the max, which is in A, or if the max is in B, I'm going to store B. So how would I do that? Well, I can use my branches now. Let's say I want to branch if the number is higher. Okay, so where am I going to branch? Okay, so now here comes use my labels. I'm going to label this place called A max. Now this only works if A is maximum. A is the max number, and over here I'm going to store my accumulator A into max. Okay? So now the way I can branch to A max is simply here by writing A max. So now it's good. After comparing A and B, it's going to branch to the higher branch if it's higher, and if the thing is, and it's going to branch to A max. Now I also have to store inside B if A is not higher. So right here is where I'd actually do that. So here I'm going to store accumulator B into max if it's higher, if that one is the one that's higher. And then the way I'm going to end my program here is by branching to quit. And let's pretend that after A max we have a label called quit, and all it does is end the program. Okay, so here we have B high, and B high, as you know, is only used if we have unsigned numbers. Okay, but what if we have a signed number that occurs? What if this number returns you? What if this A subtract B operation returns you a signed number? Okay, easy fix. Let's just change that to a greater than. Cool. Now my program is fit to deal with signed numbers, and it will work just as fine. And that's how you basically solve this problem. Okay, so now say we wanted to store something or you wanted to do the same thing, but say your numbers were inside memory location, the registers X and Y. Okay, well, that's a little harder because we don't have a command like this where we can just compare two registers together. But what we do have is two commands that are compare X and compare Y. Okay, so how are we going to do this? So first I'm going to start off the same. I'm going to start by declaring my variable max at memory location 800 again. So I'm going to reserve one memory word. And remember, word is important. Why? Because X and Y are 16-bit registers, and if you reserved a byte, you will not have enough room to store your number. Okay, so now I need a way to compare Y to X without directly comparing them. Okay, so why don't we do something here? Why don't we reserve a location here to store our memory location Y? So here I'm reserving one word here, and I'm calling it store Y, and that's exactly where we're going to store our number Y, or our number inside register Y. So now I'm going to start writing my code to figure this out. Okay, so now I'm going to start off here by taking my number inside Y and putting it inside my store Y variable right here. So I've just stored whatever is in Y into this memory location, and now we have a way to compare X to Y. Okay, so now that we have our Y in our memory location, we can use this command here to compare register X to our store Y. And then we'll do the same thing here. We're going to see if it branches high, we're going to move to something called X max. Now X max is down here, and it's just going to store X into our max, and then here we need to store Y into max if X is not greater than Y, and here we're going to branch into quit. And here I'll actually write down quit because I have room. So here is our quit label, and all it does is end the program. So if we move past, so say Y was greater than X, we would move that past this line and store Y into max. Then we'll branch to quit, so it's going to skip over this part and go straight to quit. But say we branched, say X was higher, then we're going to move to X max, and then now it's just going to follow this procedurally. Now it's going to store X into max, and then it's just going to go straight into quit. And that's how you write a program like that. It's very simple.